Dear students, we have already discussed with the basic concept of infinite series and convergency, divergency, and how to check whether the given series is convergent or divergent. And simultaneously, we have discussed what are the tests to check whether the given series is convergent or divergent, right? Now, first we have discussed with the Cauchy's root test. Now, next one is D'Alembert's ratio test. Even this ratio test also very important. The name itself indicates ratio, means you have to find the ratio of nth term and n plus 1th term and apply the limit. Okay. In general, we can call it as ratio test also or D'Alembert's ratio test. It is one and the same. Okay. Now, if summation un is an infinite series of positive terms and if limit un plus 1 by un as n tends to infinity, which is equal to L, say they will give the nth term of the series, or you can find the nth term of the series. Later you have to find n plus 1th term of the series and you have to compute un plus 1 by un and then apply the limit as n tends to infinity. Okay. Now suppose after applying the limit you will get some constant value L. Okay, then there are three possibilities. One is, suppose this L which is less than 1, then the series we can say it is convergent. As your previous Cauchy's root test only, same case here. And if L greater than 1, then it is said to be divergent. And if L equal to 1, the test fails. You no need to move further. If test fails, actually one method is there, but that method they removed from your syllabus. That is comparison test. So just you need to write, suppose L equal to 1, just you write the test fails. That's it. Okay. See, once again, they will give you the nth term of the series. You have to find un plus 1. Then compute the ratio un plus 1 by un and apply the limit as n tends to infinity. Then you will get some finite value. That finite value, suppose if it is less than 1, then we say that the given series is convergent. And if it is greater than 1, then we can say that the given series is divergent. And the test fails if L equal to 1. Okay, now you have to remember the important points here. Ratio test involves the term what? Ratio un plus 1 by un. This is the first very important note. Second one, usually we try ratio test in the following cases. See, when we are applying the ratio test, that is very important. First one, nth term of the series is not of the order 1 by n power k. Okay, that is 1 by n square, 1 by n cube, like that. Suppose if it is not in this form, you have to go for ratio test. Then nth term of the series involves variables such as x power n, x power 2n, etc. Okay. Third one, the number of factors in the numerator and denominator increases steadily from term to term. Once again, when we are applying the ratio test, that is nth term of the series, not in the order of 1 by n power k. It is not in the order of this, then you have to go for ratio test. And the term including x power n, x power 2n, x power 3n and so on, in that case also we are applying the same ratio test. And last one, the number of factors in the numerator and denominator goes on increasing from term to term, previous term to next term, the factors will be increasing in both numerator and denominator. Now, what are the procedure behind with this D'Alembert's ratio test? See, first we first write the general term un for the given series and find un plus 1 by replacing n by n plus 1. Okay, first we have to find what? General term un. Then we have to find n plus 1th term, just replacing n by n plus 1. Okay. Later, find the ratio un plus 1 by un and simplify and find its limit as n tends to infinity to decide the nature of the series. That is what? When if you apply the limit as n tends to infinity for this ratio, you will get some finite value, right? that is suppose 3. If it is, say it is less than 1, you can write it is directly convergent. Since 3 is greater than 1, so obviously it is divergent. Suppose the limit is equal to 1, then the test fails. That only here in the procedure we have mentioned. Okay. Now discuss one by one problem. See here, first problem. Test for convergence of the series 3 by 4 plus 1 plus 3 square by 4 square plus 1 plus 3 cube by 4 cube plus 1 plus dash 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 up to plus infinity. Now always see here, the numerator and denominator steadily it is increasing, right? Obviously we have to apply which rule here? Ratio test only. That is what? See here, 3 power 1 numerator, next 3 power 2, next 3 power 3. So these are the numerator values steadily increasing. What about denominator? 4 power 1 plus 1, 4 square plus 1, 4 cube plus 1. See here, again in the denominator also the terms goes on increasing. Can you write its nth term? See, for the first term power 1, for the second term power 2, for the third term power 3. In general, can you write the nth term? That is un equal to 3 power n by 4 power n plus 1. Okay, so this is un term. Now just replace n by n plus 1. So what you will get? Put n equal to n plus 1. So it will become 3 power n plus 1 divided by what? 4 power n plus 1 and plus 1 here. Now compute un plus 1 by un. Consider the ratio of these two. So what is un plus 1 by un? Right here 3 power n plus 1 divided by 4 power n plus 1 plus 1 whole divided by 3 power n by 4 power n plus 1, or divided by means here you can take multiply by 4 power n plus 1 divided by 3 power n. Now simplify this. This step is very important. Look into this. 3 power n plus 1 can be written as 3 power n into 3, right? Similarly here 3 power n only. Now 3 power n into 3 power 1. What happens? 3 power n cancel with this 3 power n. So remaining term 1 by here 3 by 1, because 3 power 1 means 3 and here 3 power n get cancelled, remaining term is 3 and this part as it is, right? That is 4 power n plus 1 divided by 4 power n plus 1 plus 1, right? Now here also you can simplify now itself by taking 4 power n common, or else after applying the limit also you can simplify, it is left to you. Now consider limit n tends to infinity as un plus 1 by un. Keep 3 outside. So limit n tends to infinity. What remains? 4 power n plus 1 divided by 4 power n plus 1 plus 1. So 3 keep constant outside as it is. And here what is common? 4 power n keep out. In the denominator also 4 power n keep out. So what happens here? Why we are taking this 4 power n outside? Because if you apply limit directly, you will get infinity by infinity, that is converting into the indeterminate form. So to avoid that, we are taking 4 power n common outside. Okay. Now if you keep 4 power n outside, what remains here? 1 remains. 1 plus 1 by 4 power n. That only we have written. 1 plus 1 by 4 power n. Similarly, if you keep 4 power n plus here 4 power n into 4 power 1, can we write it in the form of that? So if you keep 4 power n outside, what will remain? 4 remains, right? 4 plus 1 by 4 power n, right? Once again look into this part. 4 power n plus 1 can be written as 4 power n into 4 power 1 plus 1 here. Now 4 power n if you keep outside, only remaining term is 4 and plus 1 by 4 power n. Now this 4 power n, this 4 power n cancel. What remains? 3 constant. Now simplify this. 1 plus 1 by 4 power n. What is 4 power infinity? Any value raised to infinity is infinity. So 1 by infinity means 0. 0 plus 1 means 1 remains. Similarly, 4 plus 1 by infinity, because 4 for infinity is again infinity. So 1 by infinity is 0. So 4 plus 0 is 4. Right? So here 1 by 4 and into 3 is there. So 3 into 1 by 4 means 3 by 4. Obviously 3 by 4 which is less than 1. Therefore by D'Alembert's ratio test or only by ratio test, the given series is what? Convergent. Okay. Now next move to the next problem. Now discuss the convergence of the series 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube plus 4 factorial by 4 power 4. Here see once again, numerator is what? Here 1 means 1 factorial only by 1 square, okay, or 1 power 1. 1 factorial by 1 power 1. 2 factorial by 2 power 2. 3 factorial by 3 power 3. 4 factorial by 4 power 4 and so on. Now look into the numerator as well as the denominator. So here goes on increasing, right? Steadily it is increasing term by term. Similarly in the denominator case also same. It is goes on increasing, right? Now first consider, let un equal to nth term you consider. What is the nth term here? What is nth term here? 1 factorial by 1 power 1, 2 factorial by 2 power 2, 3 factorial by 3 power 3, 4 factorial by 4 power 4. Similarly, if you continue like this, n factorial by n power n, right? So that itself is nth term of the given series. That is what? Un equal to n factorial by n power n. So just replace n by n plus 1. What you will get? You will get n plus 1th term of the series, right? That is un plus 1 equal to what? N plus 1 factorial divided by n plus 1 whole power n plus 1, right? Now we have obtained un as well as un plus 1. Now consider the difference. Okay, what is that? Limit un plus 1 by un as n tends to infinite. Either you can take reverse order or it is left to you, but don't jump to confusion. See here, un plus 1 by un, it is less than 1, then only ratio test here we can say it is convergent. But here we have taken in reverse order, it is left to you. This is, I have given example because you can solve with both the methods, okay, but don't jump to confusion. If un plus 1 by un if you take, then for convergent it should be less than 1. And here un by un plus 1 we have taken, suppose if it is greater than 1 means convergent. That is very important. Don't jump to confusion. Either you can do with that method or you can do with this method. Now what is limit n tends to infinity? Un by un plus 1, that is n factorial by n power n divided by n plus 1 factorial by n plus 1 whole power n plus 1. Now simplify this. What you will get? Say here n factorial as it is, n power n as it is. N plus 1 factorial means n plus 1 factor means n plus 1 into n factorial actually. So n factorial get cancelled. What is n plus 1 power n plus 1? That is n plus 1 whole power n into n plus 1 power 1. So what happens here? N factorial also get cancelled. N plus 1 power 1 also get cancelled. What remains? N plus 1 whole power n remains divided by n power n remains. Or can you simplify? Because both the power n only. So n plus 1 whole divided by n whole power n. Can we write? Or 1 plus 1 by n whole power n. But what is limit n tends to infinity? 1 plus 1 by n whole power n, that is e. Now e is greater than 1, but we have taken a ratio in reverse order. Un by un plus 1 we have taken. So if e greater than 1, in that case it is convergent because un by un plus 1 we have taken. Or if you compute reverse order, un plus 1 by un, obviously 1 by e, it is less than 1, that means convergent. Okay, so by D'Alembert's ratio test, the given series is convergent. Students, be careful. Here I have explained the procedure un plus 1 by un. In some textbook they have given un by un plus 1. So you should not jump to confusion. Either any one method you remember properly. Either you can compute un plus 1 by un or un by un plus 1. Procedure is same, but you should remember last step. For un by un plus 1, if it is greater than 1, then convergent. And for un plus 1 by un, if it is less than 1, then only convergent. So that you have to remember. Now, once again, the discuss the convergence of the series summation n factorial by n power n whole square. What is un? Nth term directly given, n factorial by n power n whole square. What is n plus 1th term? Just replace n by n plus 1. So this will become un plus 1 equal to what? N plus 1 factorial divided by n plus 1 whole power n plus 1 power 2. Now compute the ratio. Now limit n tends to infinity un by un plus 1. So what will get? N factorial by n power n whole square divided by this term. So after simplifying, what you will get? N plus 1 whole power n plus 1 whole square into n factorial divided by n power n whole square into n plus 1 factorial. Now simplify. N plus 1 factorial is nothing but n factorial into n plus 1, right? So n factorial get cancelled. What remains? N plus 1 remains. Now look into this part. What is n plus 1 whole power n plus 1 power 2? That is multiply here. N plus 1 whole power 2n plus 2. Now in this 1 n plus 1 get cancelled because n plus 1 whole power 2n plus 2 minus 1. What remains? N plus 1 whole power 2n plus 1 remains. And n power n whole square means n power 2n. N factor cancelled in this step only. Now simplify this. Again, n plus 1 whole power 2n plus 1 can be written as n plus 1 whole power 2n into n plus 1 whole power 1 divided by n power 2n. So what is power 2n term? N plus 1 by n whole power 2n into n plus 1. That is n plus 1 by n means 1 plus 1 by n whole power 2n into n plus 1. But what is this? That is 1 plus 1 by n whole power n means e. Power 2 means e square. E square into n plus 1. But again, if you apply the limit as n tends to infinity, infinity plus 1 is infinity. Infinity into any quantity else infinity. Obviously, it is greater than 1. So, the value is greater than 1 for the ratio un by un plus 1. That means the given series is convergent. Okay. Now, let us move to the next problem. Test for convergence of series 2 by 3 into 4 plus 2 into 4 by 3 into 5 into 6 plus 2 into 4 into 6 by 3 into 5 into 7 into 8. See here, what is the next term? Can you guess? 2 first, then 2 into 4, then 2 into 4 into 6. Next what? 2 into 4 into 6 into 8 and so on. That is even multiple, right? 2, 4, 6, dash, dash, dash up to 2n. Similarly, see here 3 into 4, 3 into 5 into 6, 3 into 5 into 7 into 8. Now, what is next? Look into the difference of this. What we will get? Nth term 2n plus, say 3 into 5 into 7 into next 2n plus 1 into 2n plus 2, right? If you multiply, you will get like that. See, 2n plus 1 into 2n plus 2 ends with. Now, what is un plus 1? Just n replaced by n plus 1. Then 2 into 4 into 6 into 2 up to dash 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 2n into 2n plus 1 plus 1, that is 2. Because n replaced by n plus 1, right? Now, again similarly here, you have to write the same 2n plus 1 into 2n plus, sorry, it should be 3. It should be 3, 2n plus 3. Next term, n replaced by n plus 1 means 2n plus 4 you will get. Now, apply the ratio test un by un plus 1, this by this as n tends to infinity. Now, which term common and which term get cancelled? Here it should be 2n plus 3. So, here this part completely vanishes. See, 2, 4, 6 up to 2n. Again, this 2, 4, 6 up to 2n get cancelled. Now, 3, 5, 7 and so on here up to 2n plus 3 get cancelled. Even here 2n plus 3 get cancelled. What remains here? So finally, if you simplify, you will get Now how will you get the nth term? How to find the nth term? First you have to look into this. How to find n is here, a is 3 and n minus 1 into d. Common difference is what? 2 here, right? So 3 a plus n minus 1 into d. A is 3 here. 3 plus n minus 1 into 2. So 2n minus 2 plus 3. That is 2n plus 1. Similarly, if you continue, 2n plus 2. Okay, because of this, you will get like this. Now take the ratio. What remains? This will remain 2n plus 3 into 2n plus 4 divided by this 2n plus 2 and this 2n plus 2 get multiplied. So it will be square. Here it will be 2 only. So if you simplify 2n into 2n, see here, nth term keep outside, here also nth term keep outside, 4n square remains. Similarly here if you expand a plus b whole square, 4n square remains, keep out 4n square get cancelled. So what remains here, if you take 2n outside, here 3 by what remains here, 2n, and here also 4 by 2n. So what we will get finally at the end here, take outside 4n square plus 8n plus 4. So if you take 4n square outside, what remains here, denominator, and this one if you simplify, you will get 1 by 1, that is 1 only, right? If you apply the limit as n tends to infinity, just simplify this part and check. Now since here we are getting equal to 1, the ratio test fails, so we cannot explain the convergence and all, okay, or the d elements ratio test fails to explain the convergence. You have to write like this. Now next one, test for convergence of the series 1 by 3 whole square, next 1 into 2 by 3 into 5 whole square, 1 into 2 into 3 by 3 into 5 into 7 whole square. Now first write the nth term. Again calculate the nth term, 1 2 3 4 5 up to nth term, right? Numerator same. What about denominator? 3 5 7. Again how to find the nth term? Again it is in arithmetic progression, a plus n minus 1 into d, that is 3 plus n minus 1 into 2, common difference. So 2n minus 2 plus 3, that means 2n plus 1 remains. So what is un? 1 into 2 into 3 into up to n divided by 3 into 5 into 7 up to 2n plus 1. It's whole square, right? What is un plus 1? Just replace n by n plus 1. First you have to continue till here same. Then next term you have to write into n plus 1. Similarly 3 into 5 into 7 up to 2n plus 1 same. Just replace n by n plus 1 here. So 2n plus 2 plus 1, that is 2n plus 3. Okay. It's a whole square. Now compute the ratio. We will get what? This up to nth square term get cancelled, and here also this term get cancelled. What remains here? N plus 1 whole square, here 2n plus 3 whole square. So we are taking un by un plus 1, so it will become limit n tends to infinity 2n plus 3 whole square divided by n plus 1 whole square. Now simplify this, 4n square plus 3 into 2 into 2n, that is how much? 12n plus 9 divided by n square plus 2n plus 1. Now cancel that n square term and apply the limit for remaining nth term. Then you will get 4. Obviously it is greater than 1. Therefore the D-Alembert ratio test, according to the given condition, it is convergent, right? Because here we are taking the ratio un by un plus 1, right? Now next let us move to the next problem. Discuss the convergence of the series summation n cube minus n plus 1 divided by n factorial. Now first identify what is nth term of the series un equal to n cube minus n plus 1 divided by n factorial. Now what is n plus 1th term of the series? Wherever n, just replace n plus 1. So what we will get? N plus 1 whole cube minus of n plus 1 plus 1 divided by n plus 1 factorial, right? Now compute the ratio un by un plus 1 as n tends to infinity. That is limit n tends to infinity, what you will get? N cube minus n plus 1 by n factorial into n plus 1 factorial divided by this term, right? Now here n factorial can be written as n plus 1 factorial can be written as n plus 1 into n factorial, and here n factorial. So n factorial get cancelled. What remains? N cube minus n plus 1 into n plus 1 from this and divided by n plus 1 whole cube minus of n plus 1 plus 1. Now look at here. Here no need to multiply or no need to simplify. Why? Because see here, if you multiply n cube and n, you will get n power 4. But in the denominator, maximum power is n cube only. But for the numerator, maximum power is n power 4. You cannot simplify further because n power 4 by n cube and rest all constant. Leave that. Now n power 4 by n cube means n remains in the numerator obviously. So if you apply limit n tends to infinity for n, what you will get? Infinity only the answer. Now if answer is infinity means obviously it is greater than 1. So by D'Alembert's ratio test, if un by un plus 1 as n tends to infinity, the value is greater than 1, then it is convergent. Right? If you take in reverse order, we will get 1 by infinity, that is 0, then it is less than 1, then also it is convergent. When if you take the reciprocal of this, it is left to you. Either you can choose this way or you can choose that way. Both are acceptable. That's why we have given purposefully here. Next, discuss the convergence of the series 4 by 18 plus 4 into 12 by 18 into 27 plus 4 into 12 into 20 divided by 18 into 27 into 36 and so on. So what is the nth term of the sequence? First find a is 1 here, sorry, a is 4 here, and what is the common difference here? 8, right? Because 12 minus 4 is 8, 20 minus 12 also 8. So what is the standard form here? A plus n minus 1 into d we have to apply, right? So here what we will get? 4 into 12 into 20 into dash dash, where it ends actually. That is how to find the nth term. First term plus n minus 1 into the difference. Tn equal to a plus n minus 1 into d, right? What is a here? 4. 4 plus n minus 1 into difference, that is 8. So what? 8n minus 8 plus 4, that is 8n minus 4. Similarly, find the nth term of this, that is 18, 27, 36 and so on. What is the common difference here? 9. So a plus n minus 1 into d, that is what? 18 plus n minus 1 into 9. So 9n minus 9 plus 18. So what we will get? 9n plus 9. Similarly, if you want to continue with the n plus 1th term, just replace n by n plus 1 in the whole series. Now we can continue like this: 4, 12, 20, next 8, 10 minus 4. Next term is what? N replaced by n plus 1. So 8n plus 8 minus 4, that is 8n plus 4, right? Similarly, if you continue with the denominator 18, 27, 36, then 9n plus 9 into what? 9 into n plus 1 plus 9. That is 9n plus 9 means 18. Now it is ending with the 9n plus 18. Here previous term is this only, 9n plus 9. You can write. Now what is the limit un by un plus 1 as n tends to infinity? Just take limit n tends to infinity. Un is this term divided by this. Now divided by this term. So what will happen? Multiply with the term containing the denominator in the numerator and numerator in the denominator we will get. After simplifying here, this term and this term vanishes with this, right? Up to 8n minus 4, here up to 9n plus 9 cancels. What remains? 9n plus 18 divided by 8n plus 4. Now again here, if you take n outside and from here n outside, what happens? N get cancelled. Here 9 plus 18 by n and here 8 plus 4 by n. So 18 by n means as n tends to infinity, 18 by infinity, that is 0. Similarly 4 by n as n tends to infinity means 4 by infinity means 0 here. So 9 by 8 remains. Again, it will be 1 point something you will get, right? So obviously 9 by 8 is greater than 1. Therefore, by D'Alembert's test, ratio test, the series is convergence. Now last one problem under this. Discuss the convergence of the series 1 plus 1 square into 2 square by 1 into 3 into 5 plus 1 square into 2 square into 3 square divided by 1 into 3 into 5 into 7 into 9 and so on. Now first you have to choose un, that is nth term. What we will get? 1 square, 2 square, 3 square up to n square, right? Divided by here 1 into 3 into 5 into 7 into 9. That means what? What will you get? First term is 1, n minus 1 into common difference is 2. Now you can consider like this. Similarly, continue with the next series also. You will get 4n minus 5 into 4n minus 3. Now what is its n plus 1th term? Just write previous term as it is, then into n plus 1 whole square. Similarly here, write the previous term as it is, then 4n minus 1 into 4n plus 1 you will get. Whenever n replace by n plus 1, see here, n plus 1, 4n plus 4 minus 5, that is 4n minus 1. Now again here, if you replace n by n plus 1, 4n plus 4 minus 3, that is 4n plus 1. Okay. Now divide, take the ratio of this un by un plus 1 and simplify and apply the limit n tends to infinity. You will get limit n tends to infinity 4n minus 1 into 4n plus 1 divided by n plus 1 whole square. Again, what you will get if you simplify here, a plus b into a minus b form it is. So 4n whole square minus 1 or 16n square minus 1. Here n square plus 2n plus 1. Now take n square from numerator as well as denominator outside. Now what remains? Here 16n square minus 1. In that, if you take n square out, 16 minus what? 1 by n square. Here if you take n square outside, what remains? 1 plus 2 by, that is 2n by n square means 2 by n plus 1 by n square. So denominator part what? Here total n square get cancelled. 16 remains in the numerator. 16 minus 0 here 1, right? 1 plus 0 0. So what we will get finally? 16 by 1, that is 16. Again it is obviously greater than 1. Therefore by D'Alembert's ratio test, the series is convergent. Okay, see here once again I will repeat it. Either you can take un by un plus 1 or un plus 1 by un. It is left to you. Both the methods are valid. But if you take un by un plus 1, then the value is greater than 1 after applying the limit, then it is convergent. If it is the reverse case, un plus 1 by un, and apply the limit as n tends to infinity and it is less than 1, then also convergent. So if you take the denominator reciprocal here, it should be less than 1 for convergence, and if you take un by un plus 1, it should be greater than 1 for convergence. So remember any one of the form properly. Okay. Thank you. Here all the both the test over, that is Cauchy's root test as well as D'Alembert's ratio test. Okay. Thank you.